Alright guys, today we're going to go over section 8.1, which is matrices, and then we're going to look at how to solve some matrices. Okay, so this is an example of a matrix here where we have 1, 2, 3, 4, and you always designate the order of a matrix as the rows by the columns. So m times n, which is actually pronounced m by n. So rows by columns. Alright, so if I look at example 1a, I'm given a matrix of 2, and I need to find the order. So we always look at our rows first. So I can see that I have one row, so I know 1 is going to be the first part of my matrix. And then I look at the number of columns I have. I also only have one column, so this would be a 1 by 1 matrix. Okay. If I look at example 1b, I'm given the matrix 1, 3, 0, 1 half. Okay, first you look at your number of rows. So I have one row. Then you look at your number of columns. So I have 1, 2, 3, 4 columns. So this would be a 1 by 4 matrix. Okay, so when it asks you to find the order, you're just counting your rows and columns. For the second part of what we're going to do, we're going to actually write our own matrices. So we're going to write what are called augmented matrices. Okay, so if I'm given the system x plus 3y minus w equals 9, negative y plus 4z plus 2w equals negative 2, x minus 5z minus 6w equals 0, and 2x plus 4y minus 3z equals 4. We need to make a matrix that matches that. And when you're making a matrix out of a system of equations, you only care about your leading coefficients. So I know that I'm going to have 1, 2, 3, 4 rows. And I'm also going to have 1, 2, 3, 4, 5 columns. Okay, so I'm going to make a 4 by 5 matrix. Okay, so as I said, we only care about our leading coefficients. So I have 1, 3, 0, and negative 1 as my first one. So 1, 3, 0, negative 1. And then it's called an augmented matrix because you put a dashed line and then you also include your answer of your system as your last column. So my first equation augments to a matrix of 1, 3, 0, negative 1, and 9. If I do the same thing for row 2, then I have 0, negative 1, 4, 2, and an answer of negative 2. So 0, negative 1, 4, 2, and negative 2. Okay, if I look at my third row, I'm given 1, 0, negative 5, negative 6, and 0. So 1, 0, negative 5, negative 6, 0. And then for my last row, I have 2, 4, negative 3, 0, 4. 2, 4, negative 3, 0, 4. Okay. And the only thing you have to remember is you have to remember to put the dashed line down the middle, because that indicates that where that dashed line is, there was actually an equal sign in your original problem. Okay, if I do the same thing for 2b, I'm given the system x plus y plus z equals 2. 2x minus y plus 3z equals -1. Negative x plus 2y minus z equals 4. So I know that I have 1, 2, 3 rows, and 1, 2, 3, 4 columns. Okay. I know I need to augment my matrix, so I need to put a dashed line where my equal sign is, and then I pull my leading coefficients. So I have leading coefficients in my first equation of 1, 1, 1, and then an answer of 2. Okay, in my second row, I have 2, -1, 3, -1. And in my third row, I have -1, 2, -1, 4. Okay, so there's an augmented matrix for my second set of equations. Okay, then we're going to actually look at solving some systems. No, we're going to look at first, we're going to look at writing a system from an augmented matrix, then we're going to look at solving them. Okay, so if I look at this augmented matrix, I know that I'm going to have 1, 2, 3 equations, and they're going to have 1, 2 variables. My third row is where my answer is. So this is going to be my x column, this is going to be my y column, and then I'm going to have an equals column. So I know that I have 3x as my first equation plus 1y equals 0. If I look at my second equation, -9x plus 7y equals 4. And my third row, -2x plus 2y equals 6. Okay, you can pick any letters you want to represent your variables. Typically, though, when you have 2, you use x and y. Okay, if I look at then example 2D, I'm given the matrix -1, 4, 11, 0, 6, 3, -5, and 7. Okay, and all my dashed line is going to be an equal sign, which tells me then that I have 1, 2 equations with 1, 2, 3 variables, and my fourth column is my answers. So if that's the case, then I know that this is going to be my x, my y, and my z column. Okay, like I said, you can use any letters you want. Those are the ones I'm going to use. So for my first equation, I'm given -1x plus 4y plus 11z equals 0. And for my second equation, 6x plus 3y minus 5z equals 7. Okay, so writing equations from an augmented matrix is just working backwards. Okay, like I said last, we're going to actually solve some matrices, so solve some systems of equations using our matrices. So I'm given y plus z minus 2w equals -3, x plus 2y minus z equals 2, 2x plus 4y plus z minus 3w equals -2, and x minus 4y minus 7z minus w equals -19. Now in our last unit, you guys solved those using Gaussian elimination. Today we're going to use our graphing calculator and use matrices to solve them. Alright, so I'm going to make a matrix out of this system. So the first thing I know is that I have 1, 2, 3, 4 rows. And then I also have 1, 2, 3, 4, 5 columns. Okay, so for my first row, I know that I'm given 0, 1, 1, and negative 2 and negative 3 as my leading coefficients. So 0, 1, 1, negative 2, and negative 3. For my second equation, I'm given 1, 2, negative 1, 0, and 2. So 1, 2, negative 1, 0, and 2. Third row, I'm given 2, 4, 1, negative 3, negative 2. And for my last row, I'm given 1, negative 4, negative 7, negative 1, negative 19. Okay, and so as I said, we're going to solve that matrix using a graphing calculator. Alright, so if you get out your graphing calculator, then your screen will look like this. And we're going to put this matrix into our graphing calculator. So the first thing you're going to hit is you're going to hit second, and then you're going to hit your x to the negative 1 button, so that pulls up your matrix screen. Okay, so you've got a screen that looks like this. Then you hit enter to pull up your matrix number 1. Actually, don't do that. Hit second matrix, and then, go over to edit on the top, and then hit enter. You're going to edit matrix A. Okay, and when it starts off, it gives you a 1 by 1 matrix. But we know, based on this problem, that we have a 4 by 5 matrix. So the first thing you're going to do is change this to 4 by 5. So 4, enter, and then go over to the 1 where it gives you 1, 5, enter. So it will give you a 4 by 5 matrix on your screen. Okay, then you just start entering your numbers, and it will go across your rows. So I know my first number is 0, enter 1, enter 1, enter negative 2, enter negative 3, enter. There's my first row. Then if you go to your second row, gives you 1, enter 2, enter, negative 1, enter 0, enter 2. There's your second row. Your third row is 2, 4, 1, negative 3, negative 2. And your fourth row is 1, negative 4, negative 7, negative 1, negative 19. Okay, so if you enter all of those numbers in, then you'll have a 4 by 5 matrix that has the same leading coefficients as our original equation. There, that's probably easier to see. Okay, so then you need to go to second quit so that you can get out of that and get back to your normal screen. Once you're back to your normal screen, then we're going to do reduced row echelon on this matrix. So we go back to second matrix, and you'll notice that now next to A it says 4 by 5 because your 4 by 5 matrix is stored in letter A. If you go over to math, we're going to reduce this matrix to solve it. So we're going to keep going down until we see RRIF. That stands for reduced row echelon form, RREF. So letter B, hit enter. Okay, so now on your screen you have RREF, and it's waiting for what it wants you to reduce. So you go back to second matrix, and then hit enter on your matrix. So matrix A will show up. Okay, once you have that entered into your calculator, you hit enter, and it will reduce your matrix for you. So you're now given a matrix in reduced row echelon form, and it's giving you your answers. So what this tells us is that x is equal to negative 1. Y is equal to 2, Z is equal to 1, and W is equal to 3. Okay, so I know that x is equal to 1. I know that y is equal to 2, z was equal to 1, and w was equal to 3. Oh, x was negative 1. Okay, so each of those descending numbers represent your different letters. Okay, so let's do the same thing then for 6b, where we're given the system 2x minus y plus z equals 7, x plus y minus z plus 3w equals negative 4, x minus 4y plus 3z minus 2w equals 18, and y plus z minus w equals 1. First thing we have to do is turn this into an augmented matrix. So I know that I'm going to have a 1, 2, 3, 4 by 5 matrix again. And my leading coefficients are 2, negative 1, 1, 0, 7, 1, 1, negative 1, 3, negative 4, 1, negative 4, 3, negative 2, 18, and 0, 1, 1, negative 1, 1. Okay, so we're going to put that into our calculator. So we're going to have a 4 by 5 matrix with those leading coefficients. Okay, so if we go to second matrix, and then we go over to edit, where we're going to edit A, we are going to have a 4 by 5 matrix. So you can just hit enter on the 4 by 5, and it'll take you to your matrix. Then we're going to enter our leading coefficients. So 2, negative 1, 1, 0, 7 is my first row. 1, 1, negative 1, 3, negative 4 is my second row. 1, negative 4, 3, negative 2, 18 is my third row. And my fourth row, 0, 1, 1, negative 1, 1 is my fourth row. So now we have a new 4 by 5 matrix. I'm going to do the same thing we did before, so second quit, taking us back to our main screen. Then if we go to second matrix, go over to math, and scroll down until we find RREF. Hit enter, go to second matrix again. We're going to use matrix A because that's the one we edited. Hit enter, and it will find your solutions for you. Okay, so it finds our solutions that x is 1, y is negative 2, z is 3, w is 0. So I know that x is equal to 1, y is equal to negative 2, z is equal to 3, w is equal to 0. Okay, so when solving them, use your graphing calculator. You're going to work through 9 through 26, 63 through 72.